Let x and y be a uniform random point in the triangle in the plane with vertices 0, 0, 0, 1, 1, 0. And we are asked to find the covariance of x and y. Exercise 18 is about the joint marginal and conditional of the PDF in this setting. So we could just look that up, or we try to find it again. So let's just write out the triangle of interest. So it starts at 0, 0, goes at 0, 1. This is where x is, and it goes to another 1 in this direction. So, oops, it was a little ugly. It's a little better, not totally symmetric, but this is how it looks like. All right, so the point in the triangle, so we have 2 points basically, and everything goes within this triangle. So first of all, let's just rediscover the joint PDF of x and y. So the area of, if this would go be a total square, well, a square, we'll just complete a square like this. Well, then it would be 1 times 1, right? So that area would be 1, and the area of the triangle then is half, right? So the area of this triangle is half, and the PDF, because it's uniform, is inverse to that. So the PDF of x and y is 2. It's inverse because all points are equally likely, and so anything goes in there, and so we divide by that total area. Okay, that's good. Now what's then f of x? Well, f of x, we would have to marginalize out y. We'll marginalize out y, so that means for the area of y, it goes from, so these go from 0 to x, and well, let's see, so we have x plus y, right? So we have x plus y, that together should be less than 1. And so what we have is x is less than 1 minus y. Okay, so then when marginalizing out x, we have the following limits over the joint f of xy, which is just 2 over x, like so. Should be 2. This is 2. And so I have 2x 0, 1 minus y. And that is 2, 1 minus y. So that's the PDF of f of x. By total symmetry, this is 2, 1 minus x. Great, so now we have all the PDFs that we need for this exercise. And the covariance, so the covariance of x and y. You might ask, why do we need exactly those PDFs? Well, it is because the covariance is basically the variance of, it's like the variance of 2 variables, but now we have one variable, but we have 2 of them, and that is the expectation over x over y. And this is where we need the joint. This is where we need the marginals. And so the joint, if we, let's see, I think I'll just do the following. We'll do this here. That is over x and y. Over x and y, so we have the let's do first over so 0 to where x equals 1 minus, so it's up to, right, up to 1 minus y, and then we do over the remainder, which is 0 to 1. So basically, we're operating in 2 dimensions where we first marginalize over x, and then what remains is this 0 to 1. Okay, and then we have x, y, and the PDF we just calculated to be 2, dx, dy. Okay, so we're doing over x first, so that's squared, half, we have a 2 outside, 0 to 1, 1 minus y over y, like so, and what remains, so we have this 2 disappearing. What remains is 1 minus y squared, integrating over that area. We have 1 minus, we could do this multiple ways. We have the y as well, sorry about that. So we have the y. I think the easiest is just to multiply out this whole thing. This ends up being the integral 0 to 1. So that's 1 squared, that's just 1, minus 2y plus y squared, y, dy. That whole thing, we can split up obviously, just multiply in all the y's. One of the y's, 2y squared plus y, like so, dy, and now we take the integral over each and every one. So this is y squared, half, like that, minus 2 and be third, that, plus y 4, that, and all of them from 0 to 1. This whole thing then remains as 1/2 plus, minus 1/3, 2/3, sorry, plus 1/4. And this whole thing becomes, so it looks like the common denominator here is 12. So this is 6, 12, minus 8 plus, let's be 3, 12, right? Like so, and the whole thing that remains is, let's see, I think I've made an error here. 0 to 1. Yeah, so this is obviously not 12. So it's times 3, it should be a 3 here. So this ends up being 9, 1, 1, 12. Okay, there we go. So now we have the that expectation here, and this will be equivalent for this guy, and so this expectation is from 0, let's see, expectation over x is now 0 to 1, and then we have x, and then we have 2, 1, minus s. I think I right, so there's another little error here, which is that the these guys should be obviously in its own term, so we are calculating the density of y, we marginalize over the other. So this should be the reverse. So this is y and this is x, right? Because you have the joint. Real, what you want to marginalize out is the x side, and so we take the integral over x. What remains is a variable of y. So this here now is x2 minus x dx. Okay, and this is taking out the 2, integral 0 to 1. This is x minus x squared to x squared half, and then minus 1/3 x3. This whole thing goes from 0 to 1. What we have then remaining is half, so we have 2 half minus 1/3, like so. And this is just with a little algebra, we have 1/3 remaining here. Okay, so we have now 1/3 times 1/3 times 1/3 minus 1/12. So just write it out here. 1/12 minus 1/3, 1/3, and just what that whole thing becomes is minus 1/36. All right, so this means that the covariance of this whole thing is negative here.